Suppose you have a character in a game or a simulation and you want to use ChatGPT to guide that character's speech. Well, how can you do that? In this video, I'll show you exactly how to set up your Unity project to use ChatGPT or any other LLM that you can access via an API. To make this work, you'll need three main pieces: an API key stored somewhere safe, an HTTP client that will handle communication with the API, and the chatbots, agents, or characters that will be using the client to generate dialogue. To obtain your API key, you'll need to make an account at OpenAI or whichever site you're using, make your way to the documentation or your user profile, and find where to make an API key. This is basically your password for using the API. Keep it secret. Keep it safe. In order to keep your API key out of your project source code, in case you want to share it on GitHub, etc., you can put it in an environment file. This is a common practice. You simply make a file called .env in the top or root folder of your project and put OpenAI API key equals and then your API key or whatever other information you want to keep secret on separate lines in this file. You can make it in the terminal like this. In the project, you can create a tool that will load environment variables from this file with just a few lines of code. Next, in any scene in which you plan to use generative AI dialogue, you can place an object in the scene called a chat client to manage API calls. You can also just make a regular C# class or handle this logic separately with each chat agent. These pieces can all be rearranged however you want. I'm doing it this way because it makes sense to me. You might be able to think of a better way, I don't know. Anyway, the chat client will need to grab that API key from the .env file, and it will also need the URL of the API you're making requests to. That's a lot of letters. You can also set other properties here, like the model that you're using and the temperature or randomness of the replies that you get. You're also going to need to define a few models in order to translate the responses you get from the API from JSON to C#. First, you need to define a chat message. You can send an entire conversation to a model and have it form the next reply in the conversation. To specify the origin of the message, you need to specify the role. We could do this by making an enum. The possible roles, as defined in the API currently, are user, system, assistant, and function. User means you, the user, assistant means the GPT model that you're talking to, and system refers to the third-person instructions, kind of like stage directions in a script. It's not dialogue, just contextual information. Function refers to using specific predefined functions that you can create in GPT models. I don't know exactly how this works, so I'm not going to use it, but it's a thing that exists. A chat message just needs a role and some content. This is the actual message text. Next, set up a chat request body, which defines the request body. That just needs to be the model temperature, the maximum number of tokens to use, and the list of messages. These properties should either have the same name that is required in the documentation, or else you can translate the property names with this JSON property annotation. Next, you'll need the chat response body. This is the response you get from the API. This should match the expected response in the documentation. This has the properties ID, object, created, model, choices, and usage. You don't need to include all these properties, these are just the properties available. The main one you want is choices. This contains a response or responses from the model. The ID refers to this particular conversation history, and the model refers to the GPT model used, etc. Usage tells you how many tokens were used in the prompt and the response. A response needs an index, a message, and a finish reason. The index refers to which option if there are more than one because you can regenerate responses. The message is the text of the response, and the finish reason explains why the message ended. Either the response was too long, or it finished responding, or something went wrong. If this is a new response, the choice will be 0, the first item in the array. So, now that you have the models you need set up, you can build a request and send it. Create the chat request body by creating an instance of the C# class and the necessary properties, model, temperature, messages, etc., and convert it to JSON with the JSON convert class. Next, use an HTTP client to send the request. You'll get JSON as the response, so you'll have to convert the response to C# in order to use it in your code. Do this again with the JSON convert class to deserialize the response string as a chat response body C# model. Once you have the response, you can do whatever you want with it. I'm going to create a delegate here, so whatever agent is using this client can decide what to do with the response. They'll just need a method that takes a string. I name it callback in my public chat method. When I get the response, I'll just pass the text into the callback, and the agent can decide what to do with it. Now you can set up a chat agent. This is the NPC or whatever is using the generated text. Here, I want to send a single system message to the API in order to generate something for the store clerk NPC to say when a player arrives. You can store an entire message history in this class and keep a conversation going. This message can be built using variables like the store owner's name, their species, the type of store, the particular items they have for sale, etc. This way, you can just drag and drop this component to NPCs and change a few variables around to get a new character, or vary them randomly, etc. You can even make some characters more random than others by increasing their response temperature. Just add it as a property to the chat method on the client. I'm going to set up an NPC here using the script I made, and I'm going to call this chat method whenever the player gets within a certain distance. One easy way to do this is with the trigger collider. If a player enters the store, they'll set off the trigger. If I have a collider on a child component, I can add a rigid body component to the parent to detect a collision. When the trigger is activated, that will send a message to the API to get a response. When the response comes back, I want this to show up in a speech bubble that I have set up. So, let's try this out and see what happens.
Ah, another lost soul wanders into my humble establishment. Pray tell, what brings you to this insignificant corner of the universe? Okay, that works. Let's turn up the temperature a bit. Hello? Ah, another insignificant being graces my humble store with their presence. How quaint. What pitiful item do you seek, mortal? Jeez. Okay. It's a little more interesting. I think we can do better. Hello. Oh, yikes. Brave visitor strolls out into the abyss of commerce. Ingenious indeed to come seeking the erudition of one such as myself. Pray tell... Oh, God, I really don't want to read all that. Turned him into a dork. I thought I had it on snarky. It was on condescending. What about dorky? Let's see what that does. Hello, sir. Oh, God. Greetings, Earthling. We have the finest collection of cosmic curiosities inside of the Andromeda Galaxy, so buckle up and prepare for an interstellar shopping spree out of this world. Can I assist you in finding anything in particular? No, thanks. Let's try snarky. Hello. Finally, a delightful new pest. What cheap goods can interest you, esteemed interstellar spectre of retail agony? Alright, I'm doing business with you. I like you. I'd like to buy some carbon, I guess. Kitty, shush! Let's try turning it all the way up. Let's see what happens. This might be dangerous. Hey, what's up? Request locate equipaste copy outstanding revolving stock string. Patrick? Singapore wheel. Wow. Alright, sorry to bother you. Let's go. Let's go. Alright.